Good morning, everyone. A very warm welcome to the final session of our Lead Launch Level Up webinar series, proudly organized by TChem and TChem Campus. Over the past few months, we've had some really insightful sessions covering topics to help you grow, learn, and level up in your personal and professional journeys. Today marks the last session of this series, and we are excited to wrap it up with a truly inspiring speaker. It's now my pleasure to introduce our speaker for today, Professor Ricardo Jaramillo Godinez. Professor Ricardo is the CEO of El Lobito, a textile company based in Mexico, and a professor at Tecnológico de Monterrey, where he teaches at both the business school and the engineering and science school. He has taught over 1,000 students and has been recognized by his students as one of the best teachers at Tecnológico de Monterrey. He began his academic journey at a very young age, graduating as a technician in environmental diagnosis with honors and delivering his first conference at just 17 years old. He is a mechatronics engineer specialized in technology-based products and holds 2 master's degrees, one in engineering management and another in artificial intelligence. He also received the valedictorian recognition as the best GPA of his generation. Professor Ricardo has received several international scholarships, including from the Universidad de Burgos in Spain, Massachusetts Institute of Technology, and San Diego State University in the USA. He has worked with organizations across many sectors, such as automotive, industrial automation, aerospace, government, and food industries. He has published research in Japan, participated in IFERP 2024, and is a co-author of more than 5 academic papers. He has also spoken on Radio UNAM on the topic of the benefits and risks of AI, and he has been invited for many interviews and talks on entrepreneurship, teaching, mechatronics, and artificial intelligence. He speaks more than 4 languages, and in his free time, he enjoys traveling, painting, Asian culture, hiking, and also modeling. Please join me in giving a warm welcome to Professor Ricardo. Professor, over to you.
Oh, thank you so much. Can you hear me?
Yes, you can.
Thank you so much. Okay, thank you so much. I will start for now. So please be welcome to AI in Business, how to harness artificial intelligence for smarter decisions. Please receive a warm welcome from my part. Thank you for being here and having me here. And also I want to thank the team of TIKM. We will learn a lot about AI today. So, I know that the team of TIKM has already introduced him, but I will just don't worry, I will be a little bit faster. We won't take that long time. So as TIKM team has already told you, I am a mechatronics engineer. I have 2 master's degree. I have published already a paper in IFERP Edu Innovate in Japan, Tokyo. I am a co-author of more than 5 papers, and I am an actual researcher in entrepreneurship, engineering, and science school. As they have already mentioned, I have participated in many events, many countries. I have developed many products, and I have worked with a lot of enterprises. So I really hope that you will learn a lot at this webinar. I have also been interviewed and given many speeches and conferences about entrepreneurship, mechatronics, and how to be a better teacher here in Mexico. And as I said before, I was there in the IFERB in Tokyo, Japan, and I have given some, even as I was recognized as a valedictorian, I given the final speech at my graduation as a master in artificial intelligence. And well, I have many certificates in artificial intelligence with the IBM, with Cisco. I have also different certificates with cybersecurity, building AI solutions, building trustworthy AI enterprise solution in deep learning, many scholarships with Massachusetts Institute of Technology, with Arizona State University, and so forth. Okay, But don't worry, as I said before, it won't take me that long time to introduce myself, as the TIKM team has already introduced myself. So let me start. So let's start for the AI fundamentals. Don't worry, we will just keep the basic concepts. I will try not to be that very technical or with the coding part, as maybe some of you are more like business students or something like that. But nonetheless, this is like a user-friendly webinar, so don't worry. And please be keeping your questions. As I was told that at the end, we will have 10 minutes for questions and answers. Sorry. If you have any doubt, do not hesitate to write it down, as I will try to answer your question. Okay, so please let's begin. Okay, so for the first time, what is artificial intelligence? This is like a very basic question that most people always ask me. And there are many concepts of artificial intelligence. You can look for the NASA, the IBM, from the Cisco definition of artificial intelligence, and so forth. Nonetheless, I took the NASA definition of artificial intelligence. So what does NASA say? Well, artificial intelligence refers to a computer system that can perform complex tasks normally done by human reasoning, decision making, and creating, and so forth. But as I said before, I will keep it like very user friendly. So don't worry. Okay. So remember that artificial intelligence englobes the concept of machine learning and deep learning. And we will be talking about machine learning and also deep learning, obviously applied to business. But we have to take into account the concept or the basic concept of machine learning. So, well, machine learning stands for algorithms focus on data to train computers or to make classification, predictions, trends, right? And how about deep learning? Well, deep learning is a subset that involves neural networks with many layers, learn features automatically from data. So don't worry, I will be step by step with this concept. Okay. So before we start talking about machine learning, we have to understand what those structured data, unstructured data, and semi-structured data is. So basically, we have three kinds of data. That is very important, so you can start defining your algorithms, or maybe in which program you will be using this data, or what for, no? What is the main goal or the purpose? So that's why we are talking a little bit of what those structured data, semi-structured, and unstructured data is. Okay, so for start beginning, we have the part of structured data. So basically, structured data means that there are data that they are labeled. Basically, that ones are of the databases. They are usually text only. They are easy to search, as basically we have like these features already defined. It could be, here we have an example in the figure, the structured data. We have some examples like dates, phone numbers, social security numbers, credit card numbers, customer names, addresses, product names and numbers, transaction information, and so on, right? So normally structured data is used in supervised machine learning. So remember that is the first concept, but let's talk about semi-structured data. Okay, so semi-structured data, is data that are somehow labeled, usually need some post-processing. So there are those data are not very well defined, but we have kind of some features. It could be an example like an XML. Remember that this format of XML comes from an Excel file, for example, no? Maybe the JSON data is also like a very common data, maybe with JavaScript and those languages of programming. So those ones are very common data. Maybe semi-structured data could be also information from an email, from web pages, and so on. But semi-structured data normally, as I said before, usually needs some post-processing, so you can start labeling it, or maybe you just skip the irrelevant information, and it could also be like unstructured data. Okay, but talking about unstructured data, well, those data, they are non-labeled data normally used in unsupervised machine learning. And don't worry, we will be talking about what is supervised machine learning, what is unsupervised machine learning, and their approaches. So basically, unstructured data, here we have some examples. Remember that those are data that non-predefine data model, maybe text, images, sound, video, or other formats, and it's difficult to search, right? And there could be some examples like text files, reports, email message, audio files, video files, images, surveillance imagery, and so forth. Okay, so and before we get started with what is supervised, unsupervised machine learning, and so on, I would want to give you this scikit-learn algorithm cheat sheet because many students have already told me that where can I start, teacher? Well, the first step, and as I said to many students and many data scientists, maybe like artificial intelligence engineers and so on, is that the first step and the very first step, the most important step is like, do you have more than 50 sample data? And some of them told me no. Okay, so this is like a cycle algorithm cheat sheet, and here it says like you have to get more data. If it is a no. Well, what happens if you have more than 50 samples or greater than 50? Well, you can start selecting a category. And with that, you can start implementing yes or no questions. And maybe you can choose the correct algorithm to look at the main objective or what are you going to do with those data. So for example, you can have some algorithms with classification, clustering, regressions, and maybe with some dimensionally reduction. But well, this is public policy information, so this is for free. This is open source, so you can also look out in your web browser or internet. But I will just wanted to point it out because this is very relevant if you are doing any machine learning, any deep learning application, or artificial intelligence in general. So this is like the very basic one. Once you already have understood, sorry, the structured, semi-structured, and unstructured data. So that's why I really like to mention it here. Okay, finally, before we get started with supervised and unsupervised machine learning models, this is a general dataset rule that, well, if you have more than 50 samples of data, well, normally you want to train a model, a machine learning model, you have to keep that around 70% to 80%, it will be for training. Meanwhile, the rest of the data, the testing data, is around 20 to 30%. So basically, you have like your 100% of data. You have to separate it. 70% it will be for training, and the 30% or maybe the 20% for testing those data. Okay, so finally, but we are for so machine learning. Okay, once we already have mentioned the structured data that does the structured data, remember that those data are labeled data set. So once we have already talked about it, we can start talking about supervised learning. So this is like the very basic model. You have to understand that supervised learning is that one that trains a model to predict an output given an input. So for example, here we have a labeled data set of apple and oranges. And here we already have created a supervised machine learning model. We keep the 70% of data for training, and maybe the 30% for the test data. So here we have an example in that figure. With that test data, you start trying if your supervised machine learning model is correct. So that model will start creating some predictions according to your test data. So basically, you are asking the model that has already trained with the labeled dataset with the structured data, whether if it is an apple or an orange. So with that, you can start creating some predictions. And don't worry, we will be talking about that applied to business. I just wanted to keep the concept. As I said, that there are many business, engineering, and science students, or maybe in another field that maybe it could be the first time that they are hearing about AI. Okay. So talking about, we have already talked about supervised learning, but how about the unsupervised learning machine models? Remember that, as I mentioned before, for unsupervised learning machine learning models, you have to keep into account those unstructured data or semi-structured data. But what is the main goal of unsupervised learning? Well, those models identify intrinsic patterns, correlations, and dependencies within the data. So there are some basics of types of unsupervised learning, as here we have on the image. We have the algorithm of clustering. Even as I said before, in the scikit-learn data sheet, as I said before, that is the part of clustering. So basically, clustering is to keep some separating the data, so you can identify outliers or maybe some anomaly, as it is even here, anomaly detection. We have also the part of dimensionality reduction. That part of dimensionality reduction means that there are some very complex data sets, you can start separating some features of that data set, so that will be not that hard, or it will be simpler to understand that data. And finally, one of my favorite ones, it will be the association rule learning. I have here some real examples, so don't worry, apply to business. For the association rule learning is basically that with an algorithm, you can start implying that, and it is very used in retail. For example, if a person buys diapers, it will be probably that that person also will buy some beer. But remember that that is a prediction, right? Maybe yes, maybe not. But it is artificial intelligence based. Okay, so talking about some machine learning, we have also the part of reinforcement learning. Though these models are trying to trial and error. This is like, well, it stands for you have a machine learning model. This is like a very basic example. It will be a robot that is trying to walk. And even a child, remember that a child is trying to walk. What is the meaning of reinforcement? Well, you have an interpreter, you have a reward and a state. You have an agent, a robot, or maybe even a child. When he's trying to walk or giving his first step, right? So remember, the baby or maybe the robot is trying to start walking. It could have some errors, some mistakes when trying to walk, but that will be the action, and it's walking through an environment, right? So in that way, reinforcement learning is giving some feedback to the system, and well, obviously applied to machine learning, it is an algorithm that it is giving some feedback, and well, you have to correct this part, you have to move both legs, you have to do this, and so on. So that's why we have an interpreter, and it gives you a reward, obviously a new state. Like you have to use this kind of movement to start walking appropriately and something like that, right? So don't worry, I have here a very short video about reinforcement learning, so I won't keep you like very bored with all the theory and concepts. We have some Flappy Bird. This is like a very quick video, don't worry. This is reinforcement learning to Flappy Bird. So basically, you have this, here we have some dots, but in that sense, that Flappy Bird is trying to avoid obstacles and obviously trying to look for the success of that scenario or that level, right? So this is a very short video. Let me play it for you. So as I said before, here we have some dots, and this is a reinforcement machine learning example that it is reinforcing that system. So obviously trying to success that level, right? So well, that is a very short example. Okay, so as I said before, I don't want to be that very technical. So we can start talking about some deep learning. That remember that it is like it is after machine learning that we have understand what is machine learning. But deep learning is about inspired by the human brain. Deep learning employs artificial neural networks with many layers, or called neurons, or it could be also nodes, right? So here we have a figure. Remember that we have some neurons that one's nodes. So basically, we're talking about deep learning. That this is like a very fashion nowadays. That we have many applications like ChatGPT, DeepSeek, Meta AI, and so on. So this is like very based on that models of artificial intelligence. So this is kind of equal to a human brain. We have some input layers, we have some hidden layers, and finally an output layer. layers. So basically, like the magic happens on the hidden layers, or well, the mathematical part. I mean, each node has its own mathematical operation called activation function. So basically, the activation function happens in the hidden layers, and the input layers are those data. And remember that we have already talked about structured data, semi-structured data, and unstructured data. Sorry. And finally, we have the output layer. What are we looking for, right? And remember that deep learning is based on graphics processing unit and GPUs. This is a hardware part of your computers. So if you want to train some deep learning system, you need basic GPUs. And here we have different kinds of deep learning models. We have, for example, the convolutional neural networks, the recurrent neural networks, the transformers, and the Mamba models. As I said before, don't worry, I won't be that technical. I just want to keep the concept in mind. So once we are seeing some real examples applied to business, you can understand what kind of deep learning system is, or what machine learning model is that part applied. Okay, so for convolutional neural networks, we normally associate with computer vision, object detection, image classification, reconnection, and segmentation. So basically, you extract a part of an image, and so you start multiplying those pixels with the format of the image. We have some convolutional layer and pooling layer. So basically, talking about mathematically, remember that the part of the hidden layers or nodes, that is the convolution. We are multiplying some matrices, yes. Finally, we have an output result through an algorithm that it is called softmax. And here, finally, we have a classification result, right? So the basic one is like, for example, security cameras, no? If you are making some image classification, or maybe also in the industry, if you are making some quality management, convolutional neural networks are very important. So, but that is the basic of convolutional neural networks. Here we have also the part of recurrent neural networks. Recurrent neural networks are used in tasks that include sequential data, such as time series forecasting or natural language processing. So this is like very common for our systems like Siri, AR, artificial intelligence voices, and all those artificial intelligence assistants, right? Or chatbots. So this is like the very basic architecture of those deep learning systems based on artificial intelligence. So basically we have some input layers, some hidden layers and output layers, but it is giving feedback in that neural network. So that's why it's called recurrent neural networks. We have the part of roll or compress and the unrolled part. We have the part of transformers. This is like very important because I know that many persons use ChatGPT from OpenAI. So basically they usually ask me what kind of architecture is ChatGPT, DeepSeek, Meta AI, and something Gemini from Google, and so forth. So basically, they are transformers regarding to deep learning from artificial intelligence. So basically, a transformer is like recurrent neural networks, but the architecture only uses standard feed-forward layers, used mostly in large language model. So this is the very use in chatbots or virtual agents. Maybe when you are translating, for example, from French to English, encoding some language and then decoding it. And we have, there are more theory, but I won't take that long. There are some back forward systems with that from artificial intelligence, but that is another neural network that I wasn't talking about just right now. I just wanted to give the basic concept. And as I said before, this is another video. Don't worry, it's not that long. It is just a 5-minute video of machine learning, but maybe I will just keep like 3 minutes. This is basically that how does neural network functions. So, well, this is applied for video games, but you can also apply it for many other applications. But this is like very interesting. This is a self-system kind of reinforcement, but this is an evolutionary. But just I will just play it like 3 minutes.
Welcome back, Sethling here. You're watching a skilled player play Super Mario World, but this player is not human. It's a computer program I wrote called Mario. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player go towards the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how Mario learned to beat this level, Donut Plains 1, what his brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at Mario's brain. Let's play it again, but this time we'll look at Mario's brain as it's making the decisions of what buttons to press. It's going to look a bit complicated at first, but don't worry, I'll help break it down for you. This structure of colored lines and blinking boxes is called a neural network. It's a simple mathematical model for how a brain works, but it can produce some very complicated behavior. With enough computational power, a neural network could come close to simulating a real human brain, but modern technology isn't there yet. On the left side you have the inputs. This is what Mario sees. It's a simplified view of the level. The white squares stand for blocks the player can stand on, and the black squares stand for moving objects like enemies or mushrooms. On the right side, you have the outputs. These are the 8 buttons that Mario is able to press by using its neural network. In between the inputs and the outputs, all those lines and boxes, those are the neural network. Each free-floating box is called a neuron, and the lines connecting those boxes are like the axons and dendrites in a human brain. At any given time, only some of these neurons and connections are actually being used. And this is what people talk about when they say you only use 10% of your brain. The neural network you're seeing is a pretty complicated one, and it got so complicated as a result of a 24-hour evolutionary learning session. So, to explain how neural networks work, let's rewind about 24 hours and look at how the whole process started. This is what Mario looked like at the beginning of its training session, all the way back in generation number 0. The program is probably even dumber than you thought at this point. Often it just stands there and doesn't even press any buttons. If Mario stands still for too long, it'll cut off the simulation and try the next neural network, so it's mostly just jumping from one simulation to the next. But occasionally, the neural network says to press the right button, and the player starts walking right. Behavior isn't complicated, but it's enough to make at least some progress in the level. Let's take a look at a sample neural network to understand just how that works. This is one of the randomly generated neural networks that appeared in the first generation of the simulation. There are some green lines and a red line, and one neuron in the middle. Here's how it works.
Okay, so don't worry. I just wanted to introduce the concept of reinforcement learning and machine learning applied to video games. I have my own stopwatch, and I will try to hurry up just a little bit. Okay, so continuing with the practical applications. Once that we already have understand what is machine learning, what is structured data, what is semi-structured data, what is semi-structured data, and so forth, and what is supervised and supervised machine learning, what those deep learning system means. I have here a real application. This is a 2-minute video, so don't worry, it's just that long. This is, as remember that I mentioned you the part of transformers of natural language processing that are involved in deep neural networks. Well, here we have a real example of customer services. This is, it is not a sponsor, so sorry. This is from Forja Robotics. This is an employee training robot. There are some social robots that are based in artificial intelligence that are trying to train employees on how to give appropriate customer service. So let me play this video. It's just 2 minutes, don't worry. It's not that long.
Young lady, I'm here to return these shoes. I'm not happy.
Okay, ma'am. And what seems to be the problem with them?
My feet hurt like hell. Your idiotic manager over there, he told me that these shoes were comfortable. Well, they're not. These shoes are dreadful.
Well, these are a bit worn out. Do you have your receipt with you?
Even the color is hideous. In fact, these are not my taste at all.
Okay. Well, can I please have the receipt, ma'am?
Right under your eyes.
Okay, sorry. Yeah. Well, okay, we have a 30-day money-back guarantee, but you bought this 3 months ago, so I'm very sorry, but I cannot take this back.
I am a regular, very well-respected customer here, and you should treat me that way.
I can't take this back for you.
Ignorant child.
I can't help you for being disrespectful to me like this. You're being very unreasonable.
If you don't make the exchange at...
You did really well, Angela. But you can't tell the customers that they're unreasonable.
No, okay.
No. So try not to lose your cool next time, okay?
Yeah.
Yeah. Okay, Farhat, let's try another scenario.
Okay.
Let's do the one where the customer has a stolen credit card.
You got it.
Okay.
What do you mean this credit card is not working? Join us in creating a world where technology is more human.
Okay, so this is a very, very interesting example of how those natural language processing from deep learning models are applied in real life. This is a social robot made from customer service training, right? So let me, sorry. Okay, so for example, some another real applications with deep neural networks are the face pattern of local face features identification, and most for the part of marketing. I have also worked with many companies about this marketing part, particularly with Decathlon. That is a company that is selling goods for sports. Well, there are many enterprises that they make some videos, or maybe they record their customers when they are entering to their local shoppings. Sorry. To the local shopping centers. And well, remember that we have the basic neural network configuration. We have the input layer, the hidden layer, and finally the output. So, but for example, what is the main goal for marketing the face features identification? Well, so in that way, they can identify the expressions of the customers, and they can also make some new strategies, some recommendations of whether the customer was happy when he wasn't at the store or buying with them, or maybe he was sad, surprised, disgusted, confused, and so forth. And with that, you can maybe create new strategies, or maybe avoid customer churn, or maybe you can also start moving the parts. That's why there are many companies that they do heat maps, and in those heat maps they identify where are the parts where the customers are like, they are like surprised, happy, angry, or what kind of sentiment does that product or that part of the store makes it feel to the customer. So I also remember that I had some computer engineering science students, and they told me that they were developing these kind of applications, and they did it successfully. Nonetheless, they told me like, I don't know what to do with this, teacher. So I was saying to them, well, you can start selling it to companies. They are very interesting, and at least on the marketing part with this. So there are many companies that are very interested in this part of marketing. And remember, this is a basic application of deep neural networks, right? Okay, so talking about more about decision making from a financial profile, this part of loan approval, there are some companies, some banks, many financial institutions that they have already identified their marketing persona, or what is their customer persona. It is also called in that way. So basically, on her or his historial, they whether decide if they can do it some loans or not. But that will be with machine learning. Remember, with structured data, right? You have identified the features. But don't worry, we will talking about a little bit more just in more minutes. Okay, I will try to hurry up, as I can see that I have a few minutes. Okay, so natural language processing is also it is applied for market research, understand opinions, products, and trends. Remember, if you have already purchased some goods or products across through e-commerce applications or platforms, you have already seen this resume, or these opinions, like artificial intelligence based opinion. Like, this is like the resume of what customers are saying of these products, right? So this is natural language processing, or that is natural language processing. We have also the virtual agents, or in other words, chatbots, that attends most customer questions. We have as I said before, the retail part to summarize client-based opinions, right? So chatbots are very commonly used right now. Nowadays, they are most common. And also natural language processing is very used for sentiment analysis. Remember that there are many companies that they give you a final survey when you already have finished using their service, right? So many skyline companies told you like, please answer this post questionnaire whether you are happy or unhappy. So in that way, companies, institutions can discover people, emotions, feelings about some products or services, right? Maybe they don't implement a happy or a sad face, but maybe like a 5-star rating or something like that, right? For operations, machine learning, supervised machine learning is very commonly used for linear regressions. As you can predict some prices of goods. This is like very common use. Obviously, I know that there are some goods that maybe they don't tend to be that linear, but maybe they could be like exponential or polynomial function. But one of the most common ones is the linear regression from supervised machine learning that uses structured data, right? That data is labeled. Okay, so for the part of maintenance, we have also those artificial intelligence systems that analyze data gathered from IoT devices. Here we have, remember that we have I won't talk about cloud computing. I just want to mention it. We have the edge, the fog, and the cloud computing. And remember that there are many devices like smartwatches, credit cards, computers, cashiers, machines, medical devices that are gathering data. And then there are many companies that are very interested in those data, so they can do appropriate maintenance. Here we have a simple example of the measurement of viscosity and temperature chart. So if you are measuring or gathering those data, you can train an artificial intelligence model so you can predict whether the machine will eventually fail or not. So many companies are really interested in these kind of applications. So talking about some tools and technologies, sorry, I'm trying to be just a little bit in a hurry because I am seeing my time. Well, talking about some tools and technologies, I don't know if you have ever heard about SaaS. That means software as a service. Well, we have artificial intelligence as a service. So there are many companies that are creating applications or maybe some APIs or these complements or artificial intelligence systems. But I will give you some few examples. The most commonly used one is Amazon Web Services, AWS. We have SageMaker for machine learning models. We have Recognition for the part of vision. Remember the deep learning models. We have Lex also for natural language processing. We have Poly. Remember, Poly is from text to create speeches, right? We have other tools like Google Cloud, tools like Google Colab, some notebooks like you can create programs cloud-based, so you don't have to download locally your IDLE of a program or coding system. We have Agent Assistant, we have Vertex AI platform, frameworks, and generative AI. So you can create images, you can create maybe a marketing program, Salesforce planning, and so forth. Well, another commonly used is the IBM Cloud, the AI asset. Personally, for my master's degree in artificial intelligence, I use a lot of IBM Cloud from the artificial intelligence asset. I barely use Google Cloud, but I could tell you just a little bit, and just a little bit of Amazon Web Services, but not that much. Okay, well, I just wanted to give you some links, web pages, and book. That is another commonly question asked from my students, that they told me like, teacher, where can I start learning more about AI? Well, there are companies, for example, I have recently worked with Semantics. This is an online platform to create agents with virtual agents without code. This is like very user-friendly. We have also, you want to give a lecture or read it a little bit more, or learn a little bit more of deep learning. There is a free book that it is deeplearningbook.org. This is from MIT Press. So you can start learning a little bit more of artificial intelligence. and appropriately to deep learning systems. Okay, well, I also approached the part of transformers. I asked ChatGPT from OpenAI. This is the GPT-4 Mini. Can you give me some platforms that are applied to artificial intelligence? Of course, the artificial intelligence system said yes, right? So here I have another examples. You can also check with more time or have more calmly. But I am just a little on a hurry. Here we have Salesforce Einstein, a customer relationship management platform, CRM, that integrates artificial intelligence for data analysis, predictions, and sales automation. Here we have IBM Watson, as I said before, IBM Cloud, Microsoft Azure AI, Google Cloud AI, some chatbots like ChatGPT that based on transformers, this part of deep learning, DeepSeek, Gemini from Google. We have Tableau, we have Sia from Soho, we have Jasper, HubSpot, and HotSuite Insights. But I could tell you that most companies and even most persons, they usually use a lot of ChatGPT that it is based on deep neural networks, right? If you want to learn a little bit more of artificial intelligence, I will suggest you to start coding with Python. This is a very good book if you want to get started with some applications based in business. This is a very good book called Automate the Boring Stuff with Python. So you can start learning real code and real applications based to business. You want some courses, I will suggest you Cognitive Class AI. There are some free courses and they give you badges for free. They give you free certifications from IBM. So they are very, very good ones. Okay. So moving on, I have some talking about data-driven insights applying to business. Remember that I told you the machine learning, supervised learning. The most commonly used for this is the linear regression. So that's why I was telling you what is that structured data, what is supervised machine learning, unsupervised machine learning model, and so forth. Okay. So, well, I just keep my time, but basically here we have linear regressions from a financial institution that they are predicting what will be the credit score according to the savings of a person. So this is like a very basic graphic of a linear equation. So you can predict the credit score from a person, right? Given their savings. But how about a more complicated prediction, maybe like a loan approval by savings amounts, whether the financial institution or maybe the bank could give a loan to that person or to that company and so forth. Well, here we have this is called a function activation model. As I said before, in deep neural networks, at the hidden layers part, I mentioned that we have some activation function. This is one of them. This is called the sigmoid function activation. So basically, you program an artificial intelligence system, and if the value is greater than 0.5, it will be a yes. So obviously, maybe if you are searching or you are looking for one particular person or two persons or three persons, it will be easier. But whether you are deciding to approve a loan to 1,000 persons, that won't be that quickly, right? So you need some AI-based tools, right? So this is a sigmoid function activation function, very used for models. Okay, sorry, I will try to hurry up just a little bit. Okay, so for the business case, we have also the customer churn prediction. The logistic regression models could also help us for that. Remember that the inputs are those data. We have also the weights and the activation function that could be that I previously mentioned, the sigmoid function. So in that way, you can determine if the customer maybe could churn or not. Maybe if they are happy or they are sad. The difference between logistic regression and linear regression is that in logistic regression models, you can have more data applied to that neural network instead of just a linear equation that will be for machine learning models. Okay, you can also, for sports, apply it to predict whether one team will win or not, or maybe the performance of the players, for example, measuring the time they are running on the field, the football field. maybe the speed, the time, the fatigueness, and so forth. And this is like a heat map of where players are normally moving through the field. So you can also train some deep neural networks with that and predict and make some predictions. Machine learning and data science community, I could suggest you Kaggle. There are some very interesting uses from deep learning systems. Here we have brain MRI images from brain tumor. So with the part of vision, with deep neural networks, you can predict or determine whether if there is a tumor or maybe a cancer with just these kind of images, or these images analysis. So this is a dataset, a Kaggle dataset of Navunil Chakrabarti for medicine. For the part of clustering, or the part of unsupervised machine learning, we have some clustering. We have you can separate, start noticing some outliers, so maybe those information that remember that this is for unsupervised or for unstructured data. So you can start looking for some outliers or anomaly detections, right? And for unsupervised machine learning, we have also the association rule learning, as I mentioned you before. We have the a priori algorithms. So I know that many of you maybe have already seen these platform streams, some movies or some series like, so basically, for example, we have this Netflix that they give you some online and retail recommendations, like based that you already have seen this movie, I will suggest you this one. Or in an e-commerce platform that if you have already bought a book, maybe they will tell you, we detected that you bought this book. We will suggest you this book. So that is a real case of unsupervised machine learning applications with this associated rule learning. This is called a priori algorithms. And we have also the another practical application. We have the fraudulent pattern in financial transactions. So there are even some institutions or companies that make some frauds, or while they are detecting whether the person, maybe their incomes are greater than their expenses and something like that. And they are detecting those anomaly in data, right? In a very quickly way. So just to finish, I'm very sorry for taking just a little bit more of your time. We have some ethical and practical considerations. Well, in every company or in every institution, they must have a data governance system. So basically, we are talking about data governance systems. Is basically that they have to keep politics and procedures. So there must be rules for keeping data, access, and the elimination of data. And data governance also means that there are some roles and responsibility. Data owners, who's on data, and data stewards, the administrator of data. Well, at least here in Mexico, we have the Ley de Protección de Datos Personales, which translates to Personal Data Protection Law. I know that in your country, they could have different laws or regulations or norms. And also here people have the right to ask for their ARCO rights. That is acceso, rectificación, cancelación, oposición. That means access, rectification, cancellation, and opposition of data. And finally, yeah, with this, I am finishing this, well, at least for my part, this webinar. We have some UNESCO 10 human right approach to AI. So basically they told us like proportionally and do not harm. That is the first rule. The use of AI systems must not go beyond what is necessary to achieve a legitimate aim. The second one will be safety and security. Unwanted harms as well as vulnerability to attacks should be avoided and addressed by AI actors. So you don't have to address AI actors to keep the safety and security, right? We have the right to privacy and data protection, and this is globally, well, this is from UNESCO. We have the privacy must be protected and promoted throughout the AI's life cycle. Multi-stakeholder and adaptive governance and collaboration. International law and national sovereignty must be respected in the use of data. So you are in another country, you have to respect the local regulation, right, of data. We have the part of responsibility and accountability. The AI systems should be auditable and traceable. We have the transparency and explainability. We have the ethical deployment of AI system depends on the transparency and explainability. The next one is, human oversight and determination. The member states should ensure that AI systems do not displace ultimate human responsibility and accountability. Sustainability, AI technologies should be assessed against their impacts on sustainability. Awareness and literacy, public understanding of AI and data should be promoted through open and accessible education. And finally, fairness and non-discrimination. AI actors should promote justice, fairness, and so forth. So with that, I would want to thank you. I take a little bit more of your time. I hope that you enjoy these minutes with me. I try to be not that technical as far as as far as possible. But so let's get started with the questions and answers. Thank you so much.
Thank you so much, Professor Ricardo, for that insightful session. Yeah, we will now open the floor for questions from our participants. If y'all have any questions, y'all can ask Professor, or y'all can even drop it in the chat box. Any questions for Professor? Anything y'all want to discuss?
All good, I think.
There is no questions, Professor. I really enjoy your session today. Really insightful.
Thank you so much.
Okay, then let's wrap up. So on behalf of TChem and TChem Campus, thank you once again to Professor Ricardo for taking the time to share your knowledge and experience with us today. And also to all our participants, thank you for being part of the Lead Launch Level Up webinar series and for staying with us till the final session. We hope this series have given you useful takeaways to apply in your own journeys. So once again, thank you very much for joining us, and we hope to see you again at our future programs. Have a great day ahead.